Good evening, everyone. How are you? Happy Wednesday. In the words of the camel, Mike, what day is it? Hump day. Just a little hump day humor. Happy Wednesday. Glad you guys can come in and join me. Glad we were able to get over the hump for a day. So, I am glad that you are tuning in. You're exploring precalculus with me. I'm so glad you're gaining more understanding about it. Of course, any questions, comment them below because guess what? We're in this together, and I want to make sure that we finish and we finish strong. Now, if you have any questions or concerns, please comment them below. I'm here to help. Now, if you can hear me, please a like, a thumbs up, a heart, anything to let me know that you can hear me so we can get started. Thank you. Why, thank you so much for the thumbs up and the hearts and the likes. Let's get started, everyone. Okay, so first things first, we are going to recover the trig functions. Reason I am recovering on the trig functions because some people messaged me and let me know that they were trying to rewatch the first video from today, but the first video was not available. When I checked my information, the video's not there. But that's okay. What I teach once, of course, I can teach again. So we're going to catch a recap of the trig functions, and then we're going to move on with our today's lesson, okay? So let's get started. Now, if you remember yesterday, we covered trig functions. Trig is related to the right triangle, and it is the study of the relationship of sides and angles as it relates to the right triangle. So, depending on what angle you are discussing based on the trig functions, you will be able to do the trig functions of that angle. Okay, Miss Chris, what is all of that? What does that mean? How does this work? Well, first we're going to expand. Handy dandy graph or whiteboard. So now, if you remember yesterday, we talked about trig functions as it relates to each angle. Notice that the hypotenuse, this is very important. The hypotenuse is always the side that is opposite of the right angle. So we're dealing with right triangles, and the hypotenuse is always the opposite side of the right angle. So we are going to look at the 6 trig functions as it relates to each other angle, meaning angle A and angle B. Usually when we're dealing with trig functions, you look at the angles outside of the right triangle. You can do the trig functions of the right triangle, but usually when you're trying to find the trig functions is usually for every angle except for the right angle. So what does it look like when I try to find the trig functions as it relates to angle A? All right, let's say that we have side A, little a, which represents 3, side B, which represents 4, and side C, which will be, of course, 5. Now, trig functions are based off of Pythagorean theorem, and it's also based off of the 6 trig identities. First trig identity as it relates to angle A is sine A. Sine A, or sine theta, as it relates to angle A, is the opposite side length of A over the hypotenuse. So the opposite side length of A is the side A here at the bottom. So that means my sine A is A over C, which would be 3 over 5. Next, we have cosine A. Cosine A is the adjacent side as it relates to angle A over the hypotenuse. The adjacent side would be B as it relates to angle A. Therefore, your cosine A or cosine theta as it relates to angle A is 4/5. Next, we have tangent A. Tangent A is the opposite over the adjacent side as it relates to what angle A. Notice that each trig function is based off of angle A. Whenever you're doing your trig functions, make sure you are doing it based off of the one angle you're solving everything with. You can't go cosine A and then talk about tangent B and try to relate them because they will not be of relatable stances. Okay? So tan A equals the opposite over adjacent as it relates to angle A, which which would be A over B, which is 3/4. Now, the best way to remember sine, cosine, and tangent, if you remember, I discussed my favorite math teacher in Alabama from Ramsey High School, also my great math mentor. His name is Jesse Kelly, also known as Bruh Kelly to most and beloved by all. He taught me this saying and phrase that allowed me to remember and understand the first trig identities. Because in order to understand all six, you must first remember the first three, because the first three leads to the last three. Okay, so first thing we have is sine. Next we have is cosine, and we have tangent. Now, sine goes by the word so, and that represents opposite over hypotenuse. Cosine represents ca, which is the adjacent over the hypotenuse. And of course, tan or the tangent represents opposite over adjacent, which is TOA. Put that together and you have so, ka, TOA. And this is a phrase and term that allows you to make the connection that in order to find each trig functions first three trig functions as it relates to the angle you are using, so, ka, TOA will help you remember that so sine is opposite over hypotenuse, ka, cosine is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. Any questions as it relates to the first trig identities? All right. Next up, we do have the opposite of each trig function. And they are as follows. So, of course, you know, we are still relating this based off of angle A. So opposite of the first three trig identities is simply saying the flipped fraction or the reciprocated fraction of these trig identities. So sine has an opposite flipped identity, which typically looks like 1 over sine A. This is called cosecant, which denotes as CSC. So cosecant is hypotenuse over the opposite. Remember, sine is opposite over hypotenuse. Cosecant, which is the flipped version of sine, is hypotenuse over the opposite. So that means it is C over A as it relates to angle A, and the numbers would be 5 over 3. Next, we have the opposite of cosine. The opposite or flipped of cosine is cosine over A, 1 over cosine A, which is also called the secant. So whenever you want the flipped version or the opposite version of cosine, know that you are looking for the secant trig function. Now, the secant trig function, as it relates to angle A, is the hypotenuse over the adjacent. Cosine is the adjacent over the hypotenuse, and the secant is the flip version of that, which is the hypotenuse over adjacent. So that means that is C over B, which is 5 over 4. Now, last but certainly not least, you have tangent. Tangent's opposite, which is 1 over tangent, is cotangent. Cotangent, of course, is 1 over tan A. Also, cotangent is denoted as COT. So you have secant, SEC, cosecant, CSC, and cotangent. Those are the second set of trig identities, which are the flipped versions of the first original trig identities. So, cotangent, of course, is the flip version of tangent. Well, tangent is the opposite over adjacent. Well, cotangent is the adjacent over the opposite. And of course, that would be B over A as it relates to angle A. And B over A gives me 4 over 3. So now all you will need to remember with these 6 trig functions is sine flipped is cosecant, cosine flipped is secant, and of course tangent flipped is cotangent. And interact based on what you're trying to find with each 6 trig functions. Okay? Any questions on the trig functions identities? Now, I am going to bring up the special trig function values for special angles. Of course, these special angles are based off of the 30, 60, 90 and the 45, 45, 90 degree angles. If you remember, I showed you these different trig properties based on these special triangles, because these special triangles are of course based off the right triangle. So as you can see, you have the 30, 60, 90, the 45, 45, 90. Notice that the 45, 45, of course, are exactly the same because the angles are exactly the same. And what is sine for 30 is cosine for 60. Tangent for 30 is cotangent for 60. And of course, cosecant for 30 is secant for 60. So with each of these, you are able to determine your x, or what you're trying to find, based on these special trig functions. Typically, you use this for when you are trying to find a missing side length of a right triangle, and when you have a missing length of a side of a triangle, and it's a 30, 60, 90 or a 45, 45, you can use each of these trig value functions to find your side lengths. Here's an example of what I am talking about. So, say for instance, you have a right triangle, and that right triangle has a measure angle of 30 degrees. Now, with that measure of 30 degrees, I have the cosine or the cosecant of the cosine or the secant of this angle. Okay. Hypotenuse, which of course is opposite of my right angle, is 8. And what I'm trying to find is x. Now, you can either do the cosine, because this is the adjacent side as it relates to angle 30, or you can do the secant as it relates to as it relates to angle 30. I personally will do the cosine because cosine is usually a quicker version than the secant, but I am going to show you both. So first thing we're going to cover is the cosine. So cosine 30 is the adjacent over the hypotenuse. Now remember, the trig value of cosine 30 is the square root of 3 over 2. Because on that special list, the cosine of 30 is, by definition of trig values, the square root of 3 over 2. And of course, that equals x over 8. So you have 2x, because I'm going to cross multiply on both sides of the equal sign. Because, of course, this is considered a proportion. And proportion means I set one thing equal to another thing. I set one fraction to equal another fraction, or I set a fraction to equal a whole based on its proportion. So whenever you have proportions, we what? Cross multiply. So I multiply 2 to x, and that gives me 2x. I multiply 8 to square root of 3, and that's 8 square roots of 3. Then, of course, to solve, I divide on both sides, and x equals 8 divided by 2, 4 square roots of 3. Now, remember I said I'm going to also show you the secant. The secant of 30 is the hypotenuse over the adjacent. Because remember, secant is the flipped version of cosine. So I put my hypotenuse on top, my adjacent on the bottom. Now, secant of 30, its trig value is 2 square roots of 3 over 3. And of course, that equals 8 over x. Of course, cross multiply, and I have 2x square root of 3 over 8 times 3. That gives me 24, right? 3 times 8, 24. 2 square roots of 3 times x is 2x square roots of 3. So now, to divide, to get my x by itself, I must divide by 2 square roots of 3 on both sides. Have 2 square roots of 3 and 2 square roots of 3. And x equals 24 over 2 square roots of 3. multiplied by square root of 3 over square root of 3, because I want to get rid of my square root. X equals 24 square root of 3 over 2 times 3, which of course gives me 24 square root of 3 over 6, which of course brings me back to what? 24 divided by 6 is 4 square roots of 3. Now you see why I did the cosine instead of secant, because it's a lot. But whichever you prefer, that is your prerogative. But know that when you're doing stuff like that, that you have to get rid of the radical sign if there's a radical in the denominator. Any questions as it relates to finding the side length of a right triangle? All right, moving on, we are going to cover law of sine. The concept of law of sine is the measure of sides opposite angles with measures of A, B, and C respectively equal each other. What does that look like? What does that mean? So, law of sines. That means sine A over its opposite length of A equals sine B over its opposite length of B, which also equals sine C over its opposite length of C. As it relates to triangle, A, B, C. So of course, A to A, B to B, C to C. So now, say for instance, you are given two angles and a side. You must find the measure of the third angle, because you can't assume, well, you have to solve for the missing length and the missing angle. So you cannot assume that the angles, this is going to be based off of a right triangle. All of this will be based off of the angles that are given and how you solve them. So now, say for instance, I have angle C, which is 55, angle A, which is 45. I need to find angle B. I need to find sides A and B, and angle and my side C equals 12. First thing you want to do is find that third angle. That's going to be the simplest thing you could possibly do when trying to start doing law of sines. So, first thing you must do is find the third angle. Well, if you remember what I said about triangles way back, but let's bring it back forward. Triangles broken into its straight form is a straight line or a straight angle. Therefore, a triangle measure equals exactly 180 degrees. So, since the triangle equals 180 degrees, to find my third angle, I must add 55 plus 45 plus the missing angle in order to get 180. So now 55 plus 45 equals 100. And of course, the 100 is being added to the x, and it equals 180. Next, I subtract 100 on both sides because guess what? I'm still solving for my x. And of course, my missing angle equals 80. So x is 80, or angle B is 80. So now to find the side lengths of each side, you must base it off of the angles. Based off of the angles, you have to find sine lift A and sine lift B, and you have to base it off of the sine of these. So the law of sine, it says that, hey, if sine A is over A, it equals sine C that's over C. So now sine A, of course, is the sine of 45 degrees, and that equals the sine of 55 degrees. And we're looking for A, and C is 12. So, of course, you what? Cross multiply with these two fractions. When I cross multiply, I do 12 sine 45, because 12 times sine 45 degrees is 12 sine 45. And that equals A sine 55 degrees. Now, you don't always have to put the degree sign. You can just simply put 45 and 55. It is understood that we are measuring based off of degrees. So once we find that, then we're going to divide sine 55 on both sides because, hey, in order to find A, we must divide sine 55 on both sides. And of course, once you put this in your calculator, because you can put this in your calculator, I strongly recommend you put this in your calculator. A equals 12 times sine 45. You must multiply the 12 to sine 45 first. Then once you multiply, you must divide by sine 55. And once you do that, you must round. For rounding purposes, we are going to round to the nearest tenth, and the side length of A is 10.4. That's how you find side A based on laws of sine. Next, we have sine B of angle B over side length that is opposite of B equals sine of C, which is over the opposite side of C. And of course, sine B is 80. Sine B is sine 80. And we are trying to find the side length of B, so we will denote it and leave it as B. Then, of course, you have sine 55. And that is over 12. We still cross multiply. And cross multiplication says 12 sine 80 equals B sine 55. And of course, I'm going to divide my sine 55 on both sides. And B, of course, equals or is rounded off to the nearest tenth, 14.4. Because I multiplied 12 to sine 80 and then I divided it by sine 55. Any questions with solving a triangle based on laws of sine? Next, we have law of cosines. Now, with law of cosine, you have what we call knowing the measures of two sides and an included angle of a triangle. Typically, when you have a measure of two sides and an included angle, it cannot be solved by using law of sine. Law of sine represents the area of the same triangle. It allows you to measure two angles and any side, or two sides and the angle opposite of one of them. So, law of sine says I could either have two angles and any side, or two sides and the angle opposite of one of them. That is when you use law of sine. Now, law of cosine, typically looks like this. You have two sides and you have an angle in between those two sides. And what you're trying to find is that third side. Once you find that third side, then you can begin to do law of sine. But in order to get the third side, and you have two sides with an angle in between, you must do the laws of cosine. So the laws of cosine has three equations. Each equation is based off of the Pythagorean theorem. Of course, the Pythagorean theorem is a squared plus b squared equals c squared. Law of cosine was derived from that same theorem. So the equations as it relates to the side you are looking for, say for instance, you have triangle A, B, C. Side A is 18. Side B is 24. We're looking for side C, and the angle of C is 57. So usually when you have an angle in between these two sides, or the side angle side postulate, all of it is related as it relates to law of cosine and its functions of each one. So if I'm looking for angle, I'm looking for side, say for instance, I was looking for side A. Side A, based on law of cosine, or as it relates to cosine, its equation would be a squared equals b squared plus c squared minus 2 times the side length of B times the side length of C times the cosine as it relates to angle A. So everything, if you're trying to find side length A, this is the equation you must follow in law of cosine. If you're looking for B, of course, that's a squared plus c squared minus 2 times a times c times the cosine as it relates to angle B. And of course, c squared equals a squared plus b squared minus 2 times a and b times the cosine as it relates to c. So now, since we are looking for side length C, this is the equation we will use. So C squared equals A squared plus B squared minus 2 times A times B times the cosine as relates to angle C. Reason why? Because we're trying to find C. So now, C squared equals A squared, which is 18 squared, plus 24 squared, because B is 24, minus 2 times 18 times 24, and that is times cosine of 57. Now, when you solve all of this together, make sure that you've squared the 18, you've squared 24, you've multiplied 2 times 18, 24, and cosine 57 together. And once you have done so, your estimated answer, because with sine, cosine, tangent, you have to round to the nearest place. So to find the side length, we say, hey, to the nearest 10th place, all after we have squared and multiplied, added and subtracted PEMDAS or GEMS, depending on which system you learned from, it gives us 429.4. Now, that is what C squared equals. We still need C. How do I find C? By taking the square root of C on both sides, of C squared on both sides. Take the square root of C squared and the square root of the number on both sides. And of course, square root of C squared is C. And the estimated answer, or the rounded answer, is 20.7. Any questions as it relates to law of sines and law of cosines, all that good stuff? All right, moving on. I am going to cover in-depth information on functions. Now, if you remember at the beginning of algebra and our elementary lessons, we learned that functions mean for every x, there's exactly one y. If your x has more than one y, it is not a function. Now, if y has more than one x, it is still considered a function because y can have all the x's it wants, but for it to be considered a function at all, the x must have only one y. So if I have -3, 2 and -3, 4, well, that will give me a straight up and down line. Straight up and down line does not make a function. It makes it undefined. Anything where x equals one number or where x equals multiple numbers, or the function is x equals 2, that means it's going to be a straight up and down or vertical line. If you have a vertical line, it is not a function. Also, if you have, say for instance, we had -3, 2, -3, 4, and 4, 5. If I plot these points right now, they will not make a function. It's going to make some type of line here, and then it'll skyrocket to something like this. That is not a line. That is not a function. It has to be able to, it'll look something like this, and then it'll skyrocket into something else. It won't make an actual function because your x has more than one y. So x has more than one y, it is not a function. If you have 2, 4, 3, 4, and 5, 2, more than likely, this is going to make some type of function with a horizontal line within it. But know that even if 2 of the x's have the same y, that is still considered a function because where y equals 4, it makes a horizontal line and it passes the vertical test. If this passes the vertical test where it only hits at 1 point per x, it is considered a function. So 2, 4, 3, 4, and 5, 2, though that is considered a functional set. Now, in functions, of course, you have domains, and ranges. My domains are all my x's on a continuous function. Ranges is all my y's on a continuous function. Continuous means it is not being interrupted. So for all real numbers based on the certain function, it's going to be from -infinity to infinity. The only time you will probably really see an interruption in your continuous flow of your function is when you have a fraction and that fraction has a denominator that could potentially equal to 0. So, say for instance, you have 1 over x. Well, of course, the only x that will make this function undefined or have a blip in it, it would be where x equals 0. So the domain of this type of function is either you can put x cannot equal 0, or in interval notation, it is written as negative infinity to 0. Put parentheses because we're not including 0. And we union it with 0 to infinity. And of course, the ranges, they are from negative infinity to infinity because there is no blip in your range. Another example of this would be, say for instance, you have 2 over x squared plus 6x. Well, my range is still negative infinity to infinity because there will be no blip in my ranges. It's going to go from negative infinity to beyond. Now, for my ranges, because ranges are for my domains, of course, are always based on my x's. Well, x squared plus 6x, it cannot equal 0. So we need to know where are the blips or the asymptotes or the place where the graph becomes undefined. So to solve this, I would first factor out an x. Of course, when I factor out an x factor out of x squared gives me x. And of course, x factor out of 6x gives me 6, and they cannot equal 0. Now, because these are multiplied to each other, I can separate these from each other. So you have x cannot equal 0, and x plus 6 cannot equal 0. Therefore, if I subtract 6 on both sides, x cannot equal a negative 6. Now, set notation says I can either write it as x, where x cannot equal 0, x cannot equal negative 6, or set interval notation says that negative infinity negative 6 union with negative 6 and 0 union with, yes, there are 3 unions, 0 to infinity. Now you must do parenthesis -6, 0, only because there are numbers between -6 and 0 that can be included into the graph and not cause it to have a blip or become undefined. This is why you have 3 unions. Any questions on this part about set interval notation and finding out when your graph is undefined? Next, we have operations of functions. Operation of functions are f plus g, f minus g, f times g, and f divided by g. Usually you see this when you have 2 functions, f of x and g of x, and you are doing the operations of both of those. So you either add them together, subtracting them together, multiplying them together, or you're dividing them by each other. And you tell the domain and range based on what you've added, subtracted, multiplied, or divided. Also, you'll see something like fog, foth, goth, and Gog. Simply what that means is f of g, f of f, g of f, and g of g. This normally happens when you are finding the function as it relates to g, or the function as it relates to itself, or the function of g as it relates to f, or the function of g as it relates to itself. And typically with these, you are either trying to find out if they're inverses, or you are trying to solve for the function as it relates to that particular function. So what does all of this mean? What does this look like? How does this work? Well, best way I can show you is by getting 2 functions. And work through all of these different entity functions. Okay? So now, and I'll be able to tell you the domain and ranges based on each of these functions. Okay? So now, say for instance, I have the function of x is 5x plus 4, and the function of g of x as it relates to x is 7x minus 3. Now, what would f of x what would f plus g of x look like? All that means is I'm going to take my f of x and I'm going to add it to my g of x. So now f of x is 5x plus 4 plus 7x minus 3. You can put them in parentheses. You can leave them without parentheses. I prefer parentheses because when it comes to the adding and subtracting of functions, I want them to be on the same level. So I'm putting parentheses around 5x plus 4 and 7x minus 3. So now, 5x plus 4 plus 7x minus 3. So we know that we are adding the first function to the second function. So combine like terms. 5x plus a 7x is going to give me 12x. 4 plus a negative 3, which is also 4 minus 3, is going to give me a negative 1. Now, since this is not a fraction, my domain is all real numbers. My range is all real numbers as it relates to combining the two functions. Any questions of f plus g and of f plus g? Next up, we have f minus g. F minus g simply means I'm subtracting my function of x from my function of g. So, of course, we leave our parentheses for the function of x and g of x, which is 5x plus 4 minus 7x minus 3. So, combine like terms. 5x minus 7x is a negative 2x. 4 minus a negative 3. Well, of course, minus a negative makes it positive. So 4 plus 3 gives me a plus 7. So my answer is negative 2x plus 7. Again, we have no denominator. Therefore, my range and domain are all real numbers, or negative infinity to infinity. All right. Next, we have f times g, which of course is the function of x, times the function of f of x times the function of g of x. So that means we're going to do what? FOIL. Now, FOIL says my first terms are multiplied to each other, and 5 times 7 gives me a 35. X times x, x squared. Then I do outer, which is 5x times a negative 3. That gives me a negative 15x. Then inner, 4 times 7x. That gives me a plus 28x. And of course, 4 times a negative 3, that gives me a negative 12. Once I have FOILed 5x, 7x, 5x, negative 13, 4, 7x, 4, negative, 4, 5x, 7x, 5x, negative 3, 4 times 7x, and 4 times a negative 3. So now I bring down my 35, x squared, I combine my terms of 28 and 15, and 28 minus 15 is 8 from 5 is 3, 20 from 10 is 10. Therefore, I have a plus 13x, because 8 from 5, 3, 2 from 1, 1. So 28x minus 15x, or minus 15x plus 28x, is a positive 13x. And I bring down my minus 12. Now, this is a parabola. Parabola is a function. Parabola function will not be discontinuous. Why? Because there is no denominator that will cause a blip or an undefined moment. Therefore, my function, domain, and range is all real numbers, or negative infinity to infinity. Also, if you notice, everything is from F to G. It can be flipped from G to F, but whatever you do, make sure that whatever the question is asking for, that's exactly what you do. Also, sometimes there may be a number. What do you do when there's a number? Well, if there's a number, you first combine the terms as requested. Then the number you have, you substitute it into the equation. Once you substitute, you solve. And that's all you have to do as it relates to numbers. Now, next we have F divided by G as it relates to x, which simply is f of x over g of x. Now, of course, you know this is going to create a blip or undefined because you have 5x plus 4 over 7x minus 3. So now, when does my graph become undefined? Well, it becomes undefined when 7x minus 3 does not equal 0. So I add 3 on both sides. And 7x equals 3. Divide 7 on both sides. And x equals 3 over 7. So my set notation is going to be from negative infinity to 3 over 7, union 3 over 7 to infinity. That is for my main, and my ranges are from negative infinity to infinity because there's no blip in my ranges. Next, I'm going to cover fog and foff as it relates to foff, fog, goff, and gog, the f ofs, the f of, and the f of g, the f of f, the g of f, and the g of g. All this means is that I am substituting a function within a function. Anytime you see a O between the two functions, or an O between a function and itself, it simply means I'm going to substitute my function as it relates to the other function. So if I have f of g of x, that simply means f as it relates, g as it relates to as a function of f of x. So now you have 5x plus 4 as your function. Wherever there's an x, you are going to plug in the function of g. So the function of g is 7x minus 3. Therefore, my x becomes 7x minus 3, 5, my x becomes 7x minus 3, and of course I add my 4. Now, you have 5 times 7x and 5 times negative 3 because you distribute to each the 5. So 5 times 7x is 35x. And of course, 5 times negative 3, that gives me a negative 15 plus 4. And 35x, negative 15 plus 4, or 15 minus 4, is a negative 11. Therefore, f of g of x, or g of x, or g of x as a function of f of x is 35x minus 11. Sometimes you will see functions as they relate to themselves. So all I'm doing is taking the function of f and substituting it for the letter x. So 5 times 5x plus 4 plus 4. Distribute, and 5 times 5x is 25x. 5 times 4 is 20 plus 4. And of course, combine like terms, and you have 25x plus 24. And so the function of f as it relates to itself is 25x plus 24. All I'm doing is substituting. So for any function that you have to do within itself or to a second function, all you are doing is substituting that actual function as the letter x. Any questions on the function, the operations of functions? Well, you guys, this is really all I had for today. So, of course, if you have any questions on what we learned today, you can ask them below because I am here to help. If you have any other math questions outside of what we learned today, you can comment them below as well because I am here to help. And of course, Miss Chris is grateful that you were able to join with me on today. Of course, any questions, comment them below, and I am here to help. Other than that, I hope you are having a fantastic Wednesday, and thank you for tuning in. Well, you guys, if there are no questions, we are going to go ahead and end our live. And I just thank you so much for tuning in. I thank you for joining into this journey with me as we explore precalculus with Trig. Know that I'm just covering key components and the basic concepts of what you'll see when you go into Trig. Precalculus with Trig. Same thing as we did with Algebra 1 and 2, same thing as we have done with geometry. Know that I am always here to help for all of your mathematical needs. Other than that, I hope you guys had a fantastic Wednesday. You have made it over the hump. Let's finish the week strong. I will see you guys on Friday because we are off on Thursday. And I will see you guys on Friday at 5 p.m. Do not be late. If you need me outside of the live, you of course can reach me by IM, DM, or inbox on all my social media platforms of Krishan Mechanico or Mathematics for You Tutorial Services LLC. That can be found on Facebook, that can be found on YouTube, that can be found on Instagram, that can be found on Twitter. Also, you can text me at 205 542 5062, 205 542 5062 for all of your mathematical needs. Well, I guess this is it, guys. We are winding down, and then after that, we are going to take a break. After we take this break of relax, relate, and release, we will start back on Saturday, August the 22nd. So, if you have any questions, any concerns, if you want to get on the books to be tutored outside of the live, please go ahead and do so because the week of August 22nd, that is where a lot of people are getting ready to go back to school, prepare for school, and you definitely want to be able to get all your questions answered while live or not live, whichever you prefer. Please reach out. I am help because we're going to do math today and we're going to finish strong, okay? Other than that, my name is Miss Chris of Mathematics for You Tutorial Services LLC, where we are changing mindsets one problem at a time. Have a good night. Much love.